Okay, students, let's just start. Okay, ready?
Yes, ma'am.
Okay. Now see, we already did many things about speed, right? So now we need to do few things. Like as I told you, speed is this, speed is that. You already did lot of things, the average speed and all that. Okay, but now it's time to discuss about the velocity as well. Hmm. So now let's just discuss few things about velocity. Okay. Hmm. Okay. So the rate of motion of an object can be more comprehensive if we specify its direction and the motion along with speed. For example, if I'm giving you like Ram is walking with 12 meter per second speed. Okay. But if I'll give you that in north direction, so that means I'm talking about velocity. Sorry. See, remember one thing, when we were doing direction, who was the brother of direction? Who will tell me? Tell me. Who was the brother of direction? Jocelyn, you are not audible. Not audible. You can type it. Adil, tell me the answer. Who was brother of whom with same? It starts from D itself. Tell me.
Distance.
This. So sorry. I'm so sorry, students. It's distance. I was saying direction. So sorry. Yeah. Jocelyn got me, but still, I'm so sorry. Yeah, it was distance. I was asking you who was the brother of distance. So basically, the brother of distance is displacement. I didn't realize that I'm saying this direction. So sorry for that. In the similar way, we have speed. Okay. And who is the brother of speed? Velocity. Okay. Over distance, like direction was needed. No direction was needed. Similarly, for speed, no direction is needed. But for velocity, you need a direction. Okay. So the rate of motion of an object can be more comprehensive if we specify its direction of motion along with the speed. The quantity that specify both this aspect is called velocity. So velocity will tell you speed plus, like it will tell you the direction as well as along with the motion, right? The velocity of an object can be uniform or variable. It can be uniform or non-uniform. It can be both. It can be changed by changing the object's speed, direction of motion, or both. When an object is moving along a straight line in a variable speed, we can express the magnitude of its rates of motion is average in terms of average velocity. It is calculated the same way we calculate average speed. Okay. So now you'll be like, oh God, ma'am, what you said. Okay, so just forget everything. Just remember one thing. Distance and displacement. They were brothers. Distance, no direction was needed, but displacement, direction was needed. Right? Similarly, speed, no direction is needed, but here for velocity, you need a direction. Okay. So now we will do one thing. Like, ma'am, what is velocity? So velocity is the speed of an object moving in a definite direction. So if you are moving in a particular direction, that means I will say it's the velocity. Like if I say that if it is written like this, 40 meter per second north. So this is velocity. But if it is written only 40 meter per second, so it is your speed. Got the difference? You are not audible, students. I don't know.
Yes.
Yes. Now
Yes,
you are.
ma'am.
Yeah. Okay. So this is what. So you will write hashtag velocity. Just quickly write it down and write it like this. Hashtag velocity. Velocity is the speed of an object moving in a definite direction, or you can say particular direction. Particular direction. And this average velocity equals to displacement upon time taken. So here, see, average speed was distance upon total distance upon total time, right? But here, because velocity and displacement, they are same thing. So here, for average velocity, you will be taking displacement. You won't be taking distance. Clear?
Yes, ma'am.
Yeah. So quickly write it down.
Finish, ma'am.
Okay, Adil, you are also done?
Yes.
Now students, this is the formula. Average velocity is equal to initial velocity plus final velocity upon 2. Now you will be like, ma'am, over here you have written displacement. Okay, so we have basically two formulas for this. One is for displacement and one is for your initial and all that. Okay, so we will be discussing both the formulas over here. Wait. Hmm. See, you can see this here, average velocity, right? Yes, no? The formula you can see.
Yes, ma'am.
So you have written this formula. So first we will cover one question related to this. Okay, so first of all, you people will be telling me the displacement. For example, this is a person. Okay, he went, this is washroom, 3 kilometers. Okay, let's just take 4 kilometers. Okay, he went here. First he went here and then he came back. So now he is here right now. So tell me, what is the displacement?
2.
Distance. You can type it. Displacement and distance. He went here first, okay, and then he went back, but he stood here. He started talking to someone over here. Adil, what is six? Six is displacement or distance?
Distance.
Okay, what is displacement?
Four.
Students. This is the person. How, and this is the final position. So what is the distance between them? Like between these two. What is the distance?
2.
Justine?
Ma'am, 2.
So why you have written 3? Why you have written? Okay, okay, okay.
2.
Yeah, yeah. So sorry. I just read his answer. Okay. Justine was good. Adil, then why you are saying 4 kilometers? He went there, right? And came here. So this is how like right now he is here. So this is the initial one and this is the final one. So what is the gap between initial and final position? 2 kilometers. So why you are saying 4, 5, 6? 6 is fine. It is distance. But what about this? And Justine, you were wrong for distance. How can the distance will be 8 kilometers? This is the person. He went here, right? 4 kilometers. Then he came back here and he stood here. So 4 plus 2, na? So it is 6. You have written 8. Yes or no?
Yes, ma'am.
You people are still confused between distance and displacement. Okay. So I'm giving you two questions. This is person A, right? He went here 4 kilometers, his first friend house. Then he went here 2 kilometers, right? Then he came back and he stood here. Now, second time, he went here, 6 kilometers, and he came back here in between. Here he stood. First he went here, then he came back here. So tell me, for A, distance and displacement, and distance and displacement. Quickly. Adil, quick. Okay. So both of you people are right. I hope now you people are okay. That ma'am, this is distance and this is displacement. Is it fine?
Yes.
Yes,
Okay.
ma'am.
So what happened? Like after one class, oh my god, displacement and distance. You have to remember this for entire chapter, and next chapter also you have to deal with the same thing. So be very like particular about the things. Okay. Don't run away from numericals, because of course they'll ghost you if you'll run away. If you'll make them friend, then somewhere they'll be easy going. Okay. Now see. Wait. You have this formula and this formula as well. So see, initial velocity plus final velocity, which we'll be doing later on, but right now we'll be doing the sum with this formula only. So you have the question over here. See, Gogi went to washroom, okay, with the speed of 10 meter per second. So I'm not, okay, so Gogi went to a washroom with the speed of 10 meter per second and comes back with the speed of 2 meter per second. And the distance is 50 meters. So I'm just explaining the question. You have to give me the answer. You have to find the, see, this is Gogi, okay, and he went to washroom, okay. So the distance between the classroom and the washroom is 50 meters, okay. So when he went there, his speed was this, but when he came, his speed was this. So you have to find the average velocity. So you can find it out, yes or no? Little bit tricky, little bit. Just here, for average velocity unit displacement, you can easily find out, right? Now he is back to his classroom only, right? So you can find out displacement. Now time taken. Time taken, you have time with you, yes or no?
Yes.
Yes, ma'am.
You have time? Where's the time? I can't see it. Where's the time? You have time? This 10 meter is what? Tell me. 10 meter is 10 meter per second is what? Have you, like, for example, if I'll ask you, Justine, how much time you took, like how much time you took to complete, like to come school from your home, you will be like, ma'am, 10 meter per second. Or you will be like, ma'am, 2 hours, 3 hours, 5 hours, like this.
It's distance.
This is distance?
Yes.
Oh,
Velocity.
then what is this? This 10 meter per second is your speed, students. I have written anything 10 meter north. No, na? So that means this is speed. So with the help of speed, you can find out t,
Yes, ma'am.
right? So total time. That means t1 you have to find, t2 you have to find, right? So t1 you know the distance. For first you will find this because he went here. So first you will find t1 and the distance will remain 50, the 10. And second also the distance will remain 50 because he's coming back now. But your speed will change. So you will find t1 and t2, right? You will add them and then you have to tell me the displacement as well. And then you have to put the value and get the answer. Yes or no? No? You want me to explain it again?
No, ma'am.
Yes.
Okay. Adil, you want me to explain it?
Yes.
Okay. Okay. This is a person, Gogi. Okay, he's in classroom. He went to washroom. The distance between classroom and the washroom is 50 meters. This is washroom. Okay. He went there with the speed of 10 meter per second. So when he was going here, right, this was the speed, 10 meter per second. Right. But when he was coming back, like when he was coming back, now he is in here itself, like in the class, he came back. Okay. So his speed was 2 meter per second. Okay. So for average velocity, you have to find displacement. So displacement, you can find it out. What is the displacement? You have to check what was his initial position and where he is now. Okay. So accordingly, you will find displacement. But total time, you have to find it out. So you, like, total time is not given to you, but speed is given to you plus the distance. So you will simply use speed equals to distance upon time. This one, right? So first you will find T1. T1 you will take a distance 50 meter and speed this. Okay. And then you will find T2. Distance will remain same 50 meter but your speed will change. So T1 and T2 you will find. You will put the value. Displacement you will put the value and you will get average velocity. Now it's clear?
Yes.
Same like the second one which we did in the average speed. Right? There also time was not given to you. You have to find it out with this one. Right?
Yes,
Yes?
ma'am.
Quickly do it and let me know the answer. Adil, think about displacement. He is back he went here and he is back here only. So what is the displacement?
0.
So what will be the answer, Adil? Justine, done?
Yes, ma'am.
Okay. So see, T1, what was your T1? Basically speed equals, wait. Speed equals to distance upon time, right? So you have speed, which was your 10. So T equals to D upon S basically. So time equals to distance was 50 and this was 30, right? It was like this only. Wait. It was 10 now? Sorry, 10. So your answer is 5, right? T1 was 5. Yes, no.
Yes, ma'am.
And now other is what you wrote. Just a minute. 50 plus 50, 10 plus 2. Then what you did? How you got T1, Adil? Hmm? Speed equals to distance upon time. Yes, Adil?
Yes.
What is the speed? 10.
Yes, 10. Nice.
So what you wrote? Hmm? What you wrote, Adil? Tell me.
10 plus 2.
Is it like this? The way I am solving, or you did something very unique? Is it like this?
Yeah.
So why your answer is not 5? What's your answer? Your answer is 10. How, Adil? Like where? Just tell me where you went wrong.
I don't know.
You did it like this only. No?
No.
Okay. So now just remember it. Speed equals to distance upon time. You have speed, you have distance, but you have to find out t. So you can put a formula like this. T equals to d upon s. Because this t will go here and she'll come here. So t upon s, just put the value and get the answer. Clear? Justine and Adil, clear?
Yes, ma'am.
Yes.
Okay. You need a lot. I'll give you people lot many questions for the assignment because you need lot of, I would say, practice for displacement and distance, because if it is not clear then it is tough, right? So see, your displacement, because that Gogi went to washroom, then he came back, now he's here. So the distances, the initial position and the final position are same. So that means your displacement will be 0. T1 was 5 and that was 25. So it is 30. So 0 upon 30 is your average velocity is 0 meter per second, because whenever we divide in number, we get 0. Is it like this?
Yes, ma'am.
Okay. So quickly do the correction one. You can see over here I've written. Yeah. If you can see. Your T1 is basically 5 and your T2 is 25. Okay. Quickly do it, then we'll do the question answer.
Finished, ma'am.
Adil done?
No.
Adil, you are correct. But why you have taken this displacement 100?
It's 50 plus 50.
No, see, I'm not talking about distance. I'm talking about displacement. This was Gogi. He went to washroom, so he covered 50. Then he came back, the 50. So it is 100, the distance. But now he is here. So displacement is basically the initial position and the final position. So initial and final both are same, na? Yes.
Hey, yes.
So what is displacement? 0. Got it?
Yes.
Okay. So earlier what we were doing, for example, this is washroom. He is here. So initial position was this and the final position is this. So we were calculating the distance here, like this the distance. Right. So if, for example, if it is 4 kilometers, so it is half. So your displacement was 2 kilometers. But here he is here itself. So no distance. So that's why the displacement is 0. Now it's clear?
Yeah.
Okay. Justin, I hope you are clear, right?
Yes, ma'am.
Okay. Now basically few things. Speed and velocity. So difference between speed and velocity. So speed, total distance traveled in a given interval of time, and displacement of an object. So velocity is basically speed is total distance, okay, but velocity is displacement, right? You have written it. So speed is total distance traveled in given interval of time, and the velocity is displacement of an object even in a given interval of time. So given an interval of time, it is total distance and velocity is displacement. Okay. Speed is scalar quantity. This is vector quantity. Speed can always be positive, but vector your velocity can be positive, negative, and 0. Clear?
Yes.
Yes, ma'am.
Okay, so you'll write hashtag difference between speed and velocity. This. You write scalar. Speed is here. You can write speed always remain positive. Speed always remains positive, and velocity can be positive, negative, and 0.
Done.
Done, ma'am.
Okay, good. Now we will do the question answers. Okay. So first is a difference between speed and velocity. So you already did it. No need to write it down. See, question number second. Under what condition is the magnitude of average velocity of an object equals to its average speed? Very important question. Okay. So under what circumstances or under what condition magnitude of average velocity of an object will equals to average speed? So average velocity is going to be equals to average speed, where the magnitude of average velocity of an object will be equals to its average speed in the condition of uniform velocity, right? If they are moving with the same speed, in that case only it will be equal, right? Yes.
Yes.
Next, what does the odometer of an automobile measure? So odometer is there. So in automobiles, odometer is used to measure the distance. Very, very important question. Okay. So in automobiles, if you are going to measure the distance, how you will measure it? With the help of odometers. Clear? Jasleen?
Yes, ma'am.
Adil? Okay. Next,
Yes.
what does the path of an object look like when it is uniform? So for example, if you are moving with a uniform speed, then what will be the path look like? So in case of uniform motion, the path of an object will look like a straight line, right? If you are moving uniform, then that means you are moving a straight line. So very simple, right? Clear?
Yes.
Okay.
Yes.
So you'll quickly write down these three questions. Question number 2, question number 3, question number 4. Okay.
Yes, finished, ma'am.
Okay, Adil, you are done?
Yeah.
Okay, students. So we'll meet in the next class. Okay. So you will revise it, and today I'll share few questions to you people so that you people can do the things. Okay. And one homework for you people, kindly write it down. Writing it,
Yes, ma'am.
you have to find SI unit of distance, displacement, speed, and velocity. Okay, I'll ask you in the next class. Clear? SI unit, you'll get in the book. Just read it, you'll get it. Okay. Let's just give it, I'll just give